This creamy bar of dairy milk chocolate looks simple, but its journey is one of the most carefully controlled processes in modern food manufacturing.
You might enjoy it on the couch after dinner or as a quick treat in the afternoon.
But behind every bite is a massive factory like this, running almost around the clock to keep up with global demand. Inside, tons of cocoa, sugar, and milk are transformed into smooth, flowing chocolate with the help of powerful machines.
Today, we'll go behind the scenes to see exactly how dairy milk chocolate is made, from raw bean to wrapped bar.
Milk chocolate is the most popular type of chocolate in the world, used in bars, snacks, and even baking chips.
What makes it special is the combination of cocoa, sugar, and milk, blended so finely you can't feel any grains on your tongue.
In this video, we'll follow three main ingredients: cocoa beans, sugar, and dairy milk, as they travel through the chocolate factory.
We'll see how beans are roasted, how ingredients are mixed and refined, and how chocolate is molded, cooled, and wrapped. From the moment ingredients enter the building, strict food safety rules guide what happens. We'll start with where cocoa and milk come from, then follow them step by step through the factory.
And in the lab, you'll see how each batch is tested before it ever reaches a store shelf.
So let's begin the journey, long before this chocolate ever became liquid.
Milk chocolate's story starts thousands of miles away, in tropical regions where cocoa trees grow under the shade of taller plants.
Each tree produces colorful pods filled with cocoa beans, the seeds that give chocolate its signature taste.
The beans are scooped out and fermented in piles or wooden boxes to develop their basic chocolate flavor.
After fermentation, the beans are dried to preserve them for the long journey to the chocolate factory.
Dried beans are bagged, loaded into containers, and shipped across oceans to major chocolate-producing countries.
From there, they travel by ship and truck to specialized processing plants like this one.
At the same time, fresh milk is produced much closer to the factus, supplied by regional dairy farms.
Modern milking systems collect and chill raw milk quickly to protect its quality and safety.
The milk is filtered, tested, and often partially processed before being turned into milk powder for chocolate.
Soon, both cocoa beans and milk ingredients converge at the chocolate factory's receiving area.
Here, beans are stored under controlled conditions until the factory is ready to roast them.
Sugar and milk powder are also stored nearby, carefully separated and tracked by batch numbers. From this point on, the journey is highly organized, with each ingredient entering the factory flow at a precise time.
Next, the cocoa beans themselves are cleaned and prepared for roasting, the step that unlocks deep chocolate flavor.
Before any roasting can happen, the beans must be cleaned to remove dust, stones, and stray debris. Vibrating screens separate out small particles and dust, leaving behind only full-sized beans. Powerful magnets catch any tiny bits of metal that might have entered with the beans. Optical sorters scan each bean, rejecting discolored or damaged pieces with quick bursts of air. Only the cleanest beans continue on to the roasters, where their flavor will be transformed. Industrial roasters treat tons of beans at a time, carefully controlling temperature and time.
As the beans heat up, their natural acids mellow, and hundreds of flavor compounds develop.
The shells become more brittle, and the interior nibs loosen, making them easier to separate later.
Operators regularly sample the roast to verify flavor and aroma against the factorial standards.
Once roasted, beans are quickly cooled to lock in the desired flavor profile.
Compared to their raw state, roasted beans are darker,
drier and full of recognizable chocolate scent.
From here, roasted beans are ready for their next transformation, being cracked open and stripped of their shells. That step, called winnowing, is the key to getting pure cocoa nibs, the heart of every chocolate bar. In winnowing, roasted beans are cracked and their shells separated from the rich nibs inside.
First, a crusher breaks each bean into smaller pieces without turning them into dust.
These pieces then enter a column of moving air that helps separate lighter shells from heavier nibs. The shells are pulled one way, while the dense cocoa nibs fall into collecting bins below.
These nibs contain cocoa solids and cocoa butter, and they're what will become chocolate.
Next, the nibs are ground down by powerful mills that crush them into a thick liquid called cocoa mass.
As they're ground finer and finer, the cocoa butter inside melts, turning dry particles into a smooth paste.
The result is cocoa mass, also known as cocoa liquor, even though it doesn't contain alcohol.
This cocoa mass is the base for all kinds of chocolate, including our dairy milk chocolate.
Some of it is pressed into cocoa butter and cocoa cake, which can later be recombined in precise amounts.
Cocoa butter adds smoothness and shine, while cocoa solids provide rich chocolate flavor and color.
For milk chocolate, a controlled stream of cocoa mass is directed toward a dedicated production line. Once the cocoa portion is ready, it's time to bring in the other stars of dairy milk chocolate: sugar and milk. That happens in the mixing and pre-refining stages, where dry ingredients first meet liquid cocoa.
Sugar and milk powder are stored in large silos, kept dry and clean to prevent clumping or contamination. High-purity sugar is dosed out by weight, often measured to within a fraction of a kilogram.
Milk powder is also weighed precisely, because even small variations affect flavor and texture.
Some factories pre-blend sugar and milk powder to distribute the particles more evenly in the final mix.
Every batch follows a fixed recipe, monitored by both computer systems and human operators.
The dry blend flows into a stainless steel mixer, where it will soon be joined by warm cocoa mass. Measured amounts of cocoa mass and cocoa butter are added, beginning the transformation into chocolate.
As mixing continues, cocoa butter coats the sugar and milk particles, forming chocolate granules.
Several mixers may run in parallel, each producing a batch that will later be blended for consistency.
Samples from each batch are taken to the lab to verify fat content, moisture, and basic flavor.
Once the mix passes inspection, it moves on to refining, where those coarse granules become silky smooth.
At this stage, it still feels sandy to the touch, with particle sizes you can easily detect on your tongue.
Refiners will now crush that mixture down to microscopic particles, creating the familiar creamy mouthfeel.
Refining is where chocolate truly begins to feel like chocolate, thanks to machines like these.
The mix is fed through a series of rollers that squeeze the particles smaller and smaller. By the final roller, the gap is so tiny that the chocolate emerges as an ultra-thin film.
This delicate film is scraped off as fine flakes, now much smoother than the original granules.
Typical refining reduces particle size to around 20 microns, small enough that your tongue feels it as smooth.
Temperature is closely monitored to avoid overheating, which could damage flavor or texture.
Occasional samples are melted and tested for viscosity, ensuring the chocolate will flow properly later. These refined flakes are still somewhat dry, so they're moved onward for additional mixing and conching.
In a premixer, heat and motion start to turn the flakes back into a homogeneous chocolate mass.
Stage by stage, the ingredients transform from powder to flakes to a uniform paste.
For milk chocolate, the real magic in flavor and texture now happens in a process called conching. Conches are massive mixers that can work this chocolate for hours at controlled temperatures.
Each batch is labeled and timed because conching duration also influences the final flavor.
Let's see what happens inside these machines, where rough chocolate becomes luxuriously smooth.
Conching kneads, aerates, and heats the chocolate mass, improving its smoothness and taste.
Inside, heavy rotors constantly turn and fold the chocolate, breaking down any remaining roughness. Air exposure helps drive off unwanted volatile acids that can taste sour or harsh.
Temperature and time are carefully set, usually between 50 and 60 degrees Celsius for several hours. Operators record each batch's conditions to ensure repeatable quality from day to day. For instance, tasting remains an important part of quality control, even in such a highly automated process. As conching progresses, the chocolate becomes more fluid, smoother, and milder in flavor.
When the desired flavor profile is reached, the conche opens for the next step, fine-tuning flow and texture. Extra cocoa butter is often added now to adjust the chocolate's richness and melting characteristics. A tiny amount of emulsifier helps the chocolate flow more easily at lower fat levels.
Natural flavors, such as vanilla, can be added at this stage to round out the taste.
Special instruments measure how thick or thin the chocolate is, ensuring it will mold properly. Once the conched chocolate passes all checks, it's pumped forward to another crucial stage: tempering. Tempering is what gives chocolate its shine, snap, and resistance to melting too quickly in your hand. Tempering runs it through a sequence of cooling and gentle reheating to form stable fat crystals.
Properly tempered chocolate flows silkily, with a bright shine and perfect consistency.
Operators sometimes do a quick test by letting a sample set and checking how fast and how shiny it becomes.
If it sets quickly, with a uniform shine and no streaks, the temper is correct.
Modern tempering units measure not just temperature, but also indications of crystal formation.
The goal is to encourage stable crystal forms that give chocolate its firm snap at room temperature. Once the chocolate is perfectly tempered, it's ready to be shaped into bars, blocks, and fillings.
From the tempering area, chocolate is distributed to several molding lines running different shapes and sizes.
With just a few adjustments, the same chocolate can be poured into many different mold formats. Next, precise depositors will meter out just the right amount of chocolate into each mold.
Every cavity must be evenly filled so that each bar weighs and looks exactly the same.
Modern depositors can fill hundreds of bars per minute with surprising accuracy.
Once filled, the molds are gently vibrated to remove trapped air and level the chocolate surface.
This prevents holes or weak spots in the finished bars.
The chocolate cools slowly and evenly, allowing those tempered crystals to lock into place.
Cooling too quickly or unevenly could cause cracks or fat bloom on the surface. By the time they exit, The bars are solid, but still cool enough to handle without melting. The result is a perfect bar with crisp edges and a glossy top.
From here, different lines might add inclusions like nuts, caramel, or cookie pieces.
On some lines, nuts or crisped grains are added to the molds first, then covered with milk chocolate.
These variations use the same base chocolate, just combined with different textures.
Any bar with cosmetic defects, chips, uneven fill, or bubbles is removed from the main flow.
The bars that pass inspection now look like the chocolate you recognize from the store shelf.
Next, they'll be wrapped, coated, tested again, and packed for the trip to your local shop.
Bars are fed into high-speed wrappers that fold and seal foil or film around them in seconds. Printers mark each bar with production dates and batch codes for full traceability. Any bar that triggers the detector is removed and recorded, never allowed to enter the food chain.
Additional random samples are taken for deeper quality checks in the laboratory.
Regular cleaning and strict protective clothing help keep the entire facility food safe.
Approved bars are then grouped into cartons, sealed, and labeled for distribution.
Pallets are wrapped to protect the chocolate from dust, moisture, and damage during transport. In the warehouse, temperature is controlled to keep the chocolate from melting or blooming. From here, trucks carry the chocolate to distribution centers and, eventually, to supermarkets and stores.
Within days or weeks, the bars produced here can be sitting on shelves around the world. When you pick up a bar, you're holding the result of a long, carefully monitored chain of steps.
From farm to factory to your kitchen, each bite reflects years of expertise and precise technology.
The clean snap, smooth interior, and glossy finish all come from roasting, refining, conching, and tempering done right. The way it melts in your mouth is shaped by careful control of cocoa butter crystals and ingredient balance.
We followed cocoa beans and dairy milk from their raw forms through grinding, mixing, and molding, all the way to the final packaged bar.
Behind the scenes, factories like this quietly produce the chocolates that millions of people enjoy every day.